Hello students, welcome back. Previously in section 2, we went through the essential aspects of graphs. Literally, they were essential. Now let's go to section 3, and here we're going to focus upon increasing, decreasing nature of the graphs. Okay, I admit it, a little bit less essential comparatively speaking, but still important. Okay, here we go. Here's a definition of increasing, strictly increasing, decreasing, and strictly decreasing functions. Increasing, what do you mean by that? As x1 becomes x2, and x2 is bigger, right? As x coordinate increases, now look at the function value. F of x1 becomes f of x2. The function value gets bigger as well. So as x coordinate increases, function value also increases. The y coordinate gets larger. You see, function value is y coordinate. Or maybe I can insert something like this as well. Oops, typo. Okay, this is y1, and that's y2. So as x coordinate gets bigger, y coordinate gets bigger as well. Here's an example. As I move to the right, that is x coordinate gets bigger, y coordinate is also getting bigger. So the graph is moving up as I move to the right. Now here, y coordinate does not change, stay the same for a while. And that's okay because look at this. We have semi-inequality. So equality is okay. Whether we stay equal, so constant forever, or some extended period of time, that's okay, either way, because we have semi-inequality. And then we have a jump. That's okay too. Discontinuity doesn't matter, but jump must go up. If it goes down, we have a problem. Jump up, that's okay. And then keep going up as I move to the right. So that's an example of increasing function. Now here's an example of strictly increasing function. By the way, function value is y coordinate, so let me rewrite it like this. So as x coordinate gets bigger, y coordinate also gets bigger, but strictly bigger. Previously we had semi-inequality, now we have strict inequality. Here's an example. As I move to the right, y coordinate just gets bigger and bigger and bigger. Wait a minute, do I not have a pause right here? Not really, it's just an infinitesimal pause and then speeding back up. It's not like staying the same for extended period of time. In that case, it is increasing but not strictly increasing. In this case, it's strictly increasing. Of course, increasing is broader category, so anything that is strictly increasing is increasing too. And by the way, this is not a good color coding. I used green graphs, so maybe I should stick to green. Okay, we went through increasing versus strictly increasing. As I move to the right, graph goes up, but the big difference is whether it's allowed to stay the same for a while or not. Now, how about decreasing, going down? In this case, it's strictly decreasing too. Decreasing is a broader category, so anything that is strictly decreasing is a decreasing too. But in general, if you had something like, let's say like this, kind of like this, decrease, and then stay constant, and then like this, and then it kind of jump down. You know, these kind of things will be decreasing too, and not strictly decreasing. Here I intended extended period of horizontal line segment, so staying the same for a while. But this one is actually strictly decreasing too. Okay, let's get out of drawing mode. Finally, here is strictly decreasing. And whenever you have discontinuity, it should jump down. If it jumps up, then it's not decreasing. So we went through increasing versus strictly increasing, and decreasing versus strictly decreasing. And so far so good. It's not difficult, and students are not really confused with these kind of concepts. Now the hard part is this. What do you mean by intervals of increase and decrease? What do you mean by an interval here? It may be a little bit difficult to understand, so let's go ahead with an example problem. That'll solidify your understanding. Let's see. Graph is a little bit too small, so let's increase this. Let's magnify this. And let's answer the question. A, determine the intervals of increase and decrease. Okay. I see this a lot. Oops. A typo. Yeah, I see this a lot, but this is wrong. I see this kind of answer a lot. Decreases from, let me see, 1, 2, 3, 4, about negative 4.5, comma 4 to, let's see here, negative 3, comma 2. Did I read correctly? Increases from this negative 3, comma 2, negative 3, comma negative 2. What am I doing? This point right here, negative 3, comma negative 2 to 3, comma 3, this point, and then decrease again. To 1, 2, 3, 4, 5, 6, 7, 8, okay, 9, comma 0, kind of like this. This is a wrong solution. Do not use coordinate of these points. If you do it like this, you do not get any credit. Automatic 0 credit. The question asked you about the interval, but you gave me points. This point here to that point, and this point, and then that point. You have to answer in terms of interval. This kind of thing is automatic 0 credit. Oops. Okay, let's go over to a correct solution. Let's answer in terms of interval. The function decreases in the interval, let's see, about negative 4.5, negative 4.5 to x equal to negative 3. As a matter of fact, I think you can assume this goes on forever. You know, it hit the boundary, so assume it just goes on forever, pattern continues. And I think it's going to be better if you write like this. Negative infinity to negative 3. So x coordinate is between negative infinity and negative 3. There, function decreases. And then it increases from x equals to negative 3 to x equals to positive 3. So the interval negative 3 to positive 3. X coordinate is between negative 3 to positive 3. So here increases. And it decreases in the interval 3 to infinity. So x equals 3 all the way to infinity decreases down, asymptotically getting closer and closer and closer to x-axis. So you must answer in terms of interval of x coordinates. Intervals of x coordinate. Do not write the y coordinate. Everything must be written in terms of x coordinate as far as the intervals of increase and decrease are concerned. Let's see, what did I do in my answer key here? Okay, decreasing in the interval negative infinity to negative 3, increasing in the interval negative 3 to positive 3, and decreasing again from 3 to positive infinity, or equivalently speaking, decreasing when x is less than negative 3. As a matter of fact, everything is greater than negative infinity. So I don't need this part actually. And then increasing when x is greater than negative 3 and less than 3. And finally, decreasing when x is greater than 3. Again, everything is less than infinity, so I don't need this part. So you can write it in terms of inequality notation like this in the second line, or you can use interval notation as in the first line. The first line is a little bit better because the problem strictly asked you to use the intervals of increase and decrease. Make sense? Intervals. You have to look at the intervals in terms of the x coordinate. Let's see, do we have a similar problem here? Okay, all right, here's another problem. Determine the intervals of increase and decrease. What do you see? Increase, decrease, increase, and decrease. Do you see that? So I'll answer like this. Negative infinity to, let's see, x value negative 1. And negative 1 to 0. Yeah, negative 1 to 0. And x value 0 to 1. Let's put some spaces. And finally, 1 to infinity. So I did not write anything about y coordinate. Just look at the x coordinate, and then from negative infinity to negative 1, graph goes up, so that's increasing. From negative 1 to 0, graph goes down, so that's decreasing. From 0 to 1, graph goes up, so that's increasing. And again, 1 to infinity, graph goes down, so that's decreasing. That's how you can answer intervals of increase and decrease. Remember, look at the x coordinate only. Let's resume this section in a separate video. See you soon.